find fascinating came apart so cleanly. The J bars are here. So now I get that though, because now there's this guy's perfectly unharmed. It's inside the blister, the part of the deck that sticks out. It just knocks it off nice and cleanly, and we look at it failure like this. So we're seeing it as a downward shear also, but I'm showing you that it was a downward shear, because we saw when they released B, I'm showing you two things. One, it did that, and then when it went to failure mode, it did a lift off. It acted as something that helped lift off the back end of this and caused the failure to get it so cleanly rebars, J bars, for example. We do know that right here, level, this was about 5 inches between, using the tape measure, they show 5 inches between D1, and then over here the tape measure, of all things, is on an angle. I mean, what kind of engineer is that? He knows a tape measure on an angle gives you a different reading, but he should know that. But it's about 3 1/4 inch. You can call it 3 1/2, a difference of 1.5 inches. I'm going to use, this is the blister right here. I'm going to use my elbows and the outside of this. See the outside of the shear point we know in the OSHA report. Using my elbows, so this will be my elbow here, and the other one's over here. And this is the column, my forearms are the columns. So they were together at one point, and they still were, yeah, right. So they still are. Except for one, now it's like this. That's how you get the 5 inches on one side, and lower on the other side. So in this case, it's lower here and higher here. You see the exaggeration I did there? The column tilted when they released B. So B is right about where my mouth is. How about that? And it releases the tension. This thing drops back towards where the pier, back to the back of the pier. This already has its built-in stresses that want to resolve themselves here, as we know in the ultimate failure. So using that knowledge, we then can put a hinge point here and here. This is our creep. We put the creep there. This gives me my hinge point. Zooming out. Let me tilt up. Okay. So we know the failure, because of using the knowledge of the video, we know here and here is where it failed. So these are our hinge points. There's nothing else in there that's a hinge point for us right now. This is all we care about. So if this, when he removes B, this releases the strength of the, hey Brucey, of this acting like an upright. This caused that failure and shear and other things back here. The failure and shear, we have the crack inside here, but I think I addressed that in another video, maybe I do here. So that falls down and up, if you remember. If you look at the photographs, you'll see that you can read the wooden tape measure, the wooden measure, is 3/8 here, and then 1/2 inch over here, and in the back, I theorize it would be almost 3/4 of an inch or greater. So you're getting the back lip of the diaphragm coming up. So right here is the diaphragm. This is high here. How is it shearing down, but yet going up higher with the materials that have been sheared? Well, because they detensioned B. They didn't totally take it out. When they detensioned B, this is what saved the deck ultimately at that point. It only detensioned it, and then it cracked like hell. Once it cracked like hell, the loads were, this was already on failure, it was going to fail. It was going to keep going to the ground. But B re-energized itself, which they're not disclosing to us, had more force on it, had re-gripped, grabbed hold of with its 288,000 pounds of force, of capable force, and it's actually more than that. I think that's 70%, so it can go higher. Same thing with A, kicked in to some degree, but B is our major character here. It grabbed hold of this bottom of 12 and stopped it from going off the deck. So yes, we're looking at shear, and everybody says it's totally failed then. It's acting like a giant washer right now. It's holding the bottom of 12 is holding the deck, holding this triangle together, because it's holding the base of 12 in, albeit destroyed pretty much, you know, if you will. But at the same time, it's higher here. That means it went up and leaned in. It means it went up and leaned in. So that's our hinge point here. This deck, as I've always said in the beginning, what were the surveyors saying? What was the as-built saying? They were not hiring they were not putting a surveyor money out there to see what the bridge is doing if it's in plane. I said, drop a damn bowling ball, basketball, anything on top of this bridge, and you'll see where the low point is. It would have been here. Canopy, all bets are off. It's a radius. You can't put anything up there. It'll get trapped in the damn curb. But this, on the other hand, you might have been able to use a ball, but it does have a pitch inwards. So maybe the ball would have stopped here, or maybe the ball would have bumped into that. That's not a good thing anyway. Surveying is what you would do. You just survey down here, and the reveal should be equal down the entire deck. The reveal should be, not the pitch, the reveal. So now this hinge effect took place here. For this hinge to take place, I show this now. You guys didn't see it in the video because it cut off. But I did an exaggeration. This is 12. This is the canopy. So that's what's an exaggeration. This is where it's dipping right here. This will be there. And that's the node, if you will. So that's an exaggeration. That slight dip created that lift off up here where we get the lift up of looking at it with the OSHA reports. That explains that lift off. So it does have the failure, but it also is what's holding this bridge together at this point. That the hinging is already taken place. This is now super taut. So let's go to the brain dead guy, the one that's supposed to be so great south of Florida, southern Florida. Clearly, when they attached the B, they should have taken note that this thing was already under way beyond, already jacked up in pressure. That it was already taking a significant amount as related to A, because they stated they cycled from 50 kips to 50 kips back and forth. To get the 288 kips. How did they determine that? It's elongation, it's magic marker, it's thread count. How did they determine it was 50 kips, 50 kips, 50 kips, 50 kips? What did they base that on? Because this is already starting at a point of being stressed, being maxed out. Number B is already holding this damn structure together, holding these thousands, tens of thousands, I might be reaching on that. Maybe about 10,000 pounds. I could probably just get away with saying that. Probably 10,000 pounds of dead load here, plus the canopy area here. Right about here is where I did this. Maybe this part of canopy is not being taken care of in C2 and C4. Here's the iffy part, the funny part, and not funny at all. Once this deflects a little bit, this is no longer acting the way it is. The joint is now where the loads are going down and back up. That's your profile now. Now I'm exaggerating the profile. Right. I'm exaggerating the profile, but these anchor points, this anchor point which is down here, needs to be stable. It needs to be permanent in space. Permanent, and this is space here, right? So it needs to be permanent in space. It cannot move inwards. If it does, it's just a slippery slope. You know, you're going to fall over the cliff, literally. So, you know, literally, engineering-wise, up and down your anyway, so this moved in a little bit. This keeps pushing the scale in that direction downwards. The stresses are in B at that point. They come up there, they claim that they did 50, 50, 50. One guy's dead, the other one's brain dead. How did they determine they did it in 50, 50, 50s? It failed right after they did it, right after the bridge, they were on the bridge still. Where did they get somebody else is supposed to have made note of this. One guy's dead, one guy's brain dead. You know, he doesn't recall what happened. And he was their head guy. So who are we trusting to give us this 50, 50, 50, 50 response? Who's this other person? They weren't mentioned to be the person to give up 50, 50, 50. So that's where I was looking for some awesome disclosure from the OSHA FOIA request. That's gone downhill right now. All right, so that's questionable. So I'm going to terminate this video, I think. I know I said it already. I just wanted to give you guys a little energy to see what's going on here. Is that the foundation is probably what failed. The same thing that FIG did way back in the day, disrespecting the foundation. Also, the load paths, they didn't understand that that tensioning 2 and 11 would actually create a load path down 10 and 3, and we know that because they didn't support underneath of it with transverse cables. I'm doing a summation now for Marmalade. So, so that they don't have the transverse cables supporting it across D2 through D6, including D1. D1 is present, that's why I stated that way. So, if or they do know it's coming down there, and they're like, it doesn't matter. We calculate to be, you know, whatever. But that's not true, because the CEI, who has access to everything, stated that, to the plans rather, stated he thought this was tension cracks and he wanted to know why. He thought it was tension cracks and he wanted to know why. How did they come about it? And he, as far as I know, he never got the answer. But I think this is the answer here. It's the answer here. That their calculations, and a lot of you guys are computer model people. I saw a couple more comments on that. I'm not a computer model person. I am a visual, intellectual model person. I stood here and looked at this structure as it's falling. This is how I do it, guys. So somebody said something, and I'm gonna end the video with that so you can see my freakiness. So I stood there looking at it, and I get to look at each thing using my knowledge of what I know, and I even feel like the bridge might be rocking, and I said, no, it can't rock. It's on the pedestals. What's happening behind me? What's happening in front of me? I stand there and I can look at it. At some point, I'm behind the crane now, where we can't see from the crane, and I look up, and I can see how it would want to come apart, you know, like this, tearing apart. Here, yeah. As I'm standing here, I can see where it want to tear apart here and crush here, but I still have it entangled here still. But now I can step outside the deck and I can see, okay, this creates that breaking effect, and I can watch it and look at it and go, okay. And I count for every single crack when I do this. I need to see, I look down there and I visualize that crack when the decks shift, when they release the loads and it dropped off and it shift. I visualize the post-tension bar B inside above my head here, inside there, pushing when it did that it pushed the base by my elbows, and that's why you see that wooden plastic measurer against the column of 11 at the base, and we see it's further in and out. You know, they're not in plane. Because the rod in the middle also is, when it did its torque effect, the rod still wants to stay relatively straight. The torque effect is shown more maxed out where you see the crack stop in column 11. So that torque that I mentioned, using crack analysis, I determined that the torque effect stopped at where you see the crack stop on 11. So I can visualize all this stuff. I'm a crack nut job. I want to say a crack expert, but I said I'm not there yet. I mean, this would be nice. Give me a PhD on this one, but crack. I came up with another word before starting this video, and I was like, ooh, I'll take that as my step before expert. I'm a crack expert, I think, once I can tell you how not to get cracks around pipes in the ground. I'm almost there. I'm there. I'm doing quite a few more experiments. I'm doing everything from triangles to glass in the ground to broken glass in the ground, you know, wrapped around concrete. I'm like right there. I can control it all, but I'm trying to find one that I can't control, and that's why I'm doing random things like glass and these sharp edges, irregular edges. I can control the cuts the cracking right now of no cracking. Still working on it though. Still working on it. So in other words, I can make it so there's no cracks around here if I can have a stable area. All right, if it's not stable, it's not stable. We talk about right here. This is the beginning. I'm going to end it with this one because I didn't know if I mentioned that. I used blue ink here, This is the beginning that tells you the deck is dipping here. This was why it was still in the staging area, as reported by the CEI, one of these cracks here. This crack is the dipping area, the one I spoke of a long time ago. Could it be biased? No. I mean, my crack analysis is really open for anyone to talk to me about it, and I won't take offense to you if you want to talk to me about cracks, and you find my crack theory, any of my crack theories wrong or different. Well, we can talk about it. We can talk about it. I'm willing to change. I'm willing to learn. But I don't get myself being wrong with this one. All right, so that was the beginning. All right, love you guys. Lots of fun. Not really. I'm so glad to see this come to an end. I just need to fine-tune some things. I need to get more photographs. I love some of the scaffolding. I know there's one out there with all the scaffolding in place, all right, but I would want to know the foundation. I want to know what the scaffolding looked like under here. I want to see the scaffolding after it was removed. I want to look for buckling in any of the scaffolding members. Of course, that's going to be all destroyed by now. Interesting. I really want to know about these rods that were removed and melted down. Those I find amazing. You would destroy that. That was some beautiful evidence. It makes me look in that direction, but I don't want to look there just because of that. It could be smoke and mirrors. The real smoke and mirrors here is 50-50, 50-50, and somehow been reported by whom? Who reported they did 50-50? Were they documenting it? Again, what was the starting point of B? And also of A. What's the starting point of A when they started with the 50 kips cycling the revolutions? When did they start? How did they deduct for friction inside they were concrete? How did they deduct for friction down here where they're trying to overcome reclamping this? Because you told me you were doing it back to 288. Well, this is friction now, and friction gives you a false torque, a false reading. So, how did they do that? Yeah. All right. So ultimately, this when they attempt to reclamp, perhaps they were way over 288. The clamping force didn't buckle. This didn't buckle. And one of all of our earlier theories when we didn't have a video, that this must have buckled, thinking it was a truss system. It's not. So now we're beyond that. So in a clamp force system like this, unless you have a deviation, we're going to look at 2 points. I'm going to look at 2 points. I'm going to look at the plates on each end and see how those forces are being addressed. I'm going to look for uniformity between these two paralleling each other. Obviously, I don't want tug of war going on here. Tug of war. All right, so I really do have, I'm going to end the video now, but I really do have a tug of war theory I'm working on, how to beat tug of war with equal amount of weights and using a force multiplier, somehow wrapping the ropes around your waist. So tug of war is something I really enjoy working with. Tug of war, what if A is pulling this much and B is pulling this much? Is that not an imbalance, a tug of war between these two? What is the effect of that tug of war on this? Is that tug of war, would the effect be to actually cause this to flip up? It was already trashed. I'm just adding that for fun. This was already trashed. So you can do the tug of war thing. You can join it here. You can try to find anything wrong with my system. I'm willing to talk to you about it. I am willing only to change a couple of things. Not willing to change these. This is not negotiable. These cracks are not negotiable. This had to have deflection. What happened when they D1? Not negotiable unless all of a sudden they changed the data stating that, yeah, they tensioned D1 through D6 and then the transverse cables. Yeah, I don't find that to be, that's not playing fair as far as the release of the data. I'm going with the data as we currently have it. All right, love you guys. Bye.